Since you're missing the lesson today because of the taste day going on, I just wanted to screencast it to give you an opportunity to take the notes in your books. So today we're going to look at the different muscle fiber types and their characteristics and why they suit their role. So ignore this, it's just what we did at the start of the lesson with the other tutor group. Got them to do these 3 activities, and then we went into the muscle fiber types. We looked at the 3 muscle fiber types. So first is type 1, then type 2A and type 2B. So type 1 is also known as a slow oxidative fiber. 2A is known as a fast oxidative glycolytic fiber, whereas type 2B is a fast glycolytic fiber. Following this information, I asked the students to consider which activity used predominantly which fiber type. So type 2B was used in the standing long jump because it's a fast glycolytic, so it uses glycogen as a fast twitch fiber. So it's used for very powerful movements. 2A was the 1 minute press up test, whereas type 1 was the bring Sally up squat challenge. So type 1. Type 1 muscle fibers are slow twitch. They twitch really, they contract really slowly, and they can contract over a long period of time. What I mean by that is, by contracting over a long period of time, they don't fatigue very easily, so they you can just keep going. So when you're walking, you can use type 1 muscle fibers. They're red in colour due to the capillary density. They need a lot of oxygen because they're working over a long period of time, and because capillaries are there as blood vessels, it causes them to be red in colour. They fire they fire slowly because they're a slow twitch fiber, and they're suited to endurance type sports. So type 2A, this is now a fast twitch fiber. However, it's got characteristics of both a type 1 and a type 2B. So it's what I like to refer to as a hybrid fiber type because it has characteristics of both. So it uses both aerobic and anaerobic energy pathways, meaning it can use oxygen or it can use glycogen to supply the energy. They're also red in colour because they have a decent capillary network. They fire quickly though because they're a fast twitch fiber, so they will fire quickly. These are the ones which you can manipulate in training. So naturally, when you're born, you've got a certain amount of type 1 and type 2B fibers. The type 2A1, sorry, they can take on the characteristics of a type 1 or a type 2B, so you can make them more closely related to one fiber type, and this is what you do during training. And it's more suited for middle distance running, so think about like a 400 to 800 meter run. Right, type 2B. We got quite quick, aggressive music now, because it's the fastest of all the fiber types. It's white in colour, it doesn't use oxygen at all. Therefore, we don't need capillaries present. It uses only anaerobic energy pathways, and it fires very quickly and produces the most powerful contractions of all 3 fiber types. However, because they don't have a constant supply of oxygen, once you use your glycogen up, they fatigue really quickly because there's no constant energy supply. So it's suited to power events like sprinting. Right, this table just really sums up the fiber types. So if you look on the left hand side, we've got the different characteristics. So you've got speed of contraction and how fast. What I mean by that is how fast do they actually contract. So obviously you're expecting type 2B to be quicker than type 1, which is a fast twitch. Force contraction, how much force is actually produced while they're contracting. The size is how big the fiber type is. Mitochondrial density, so you should remember the mitochondria is the powerhouse of a cell and is responsible for aerobic respiration. Therefore, type 1 will have the highest mitochondrial density. What we mean by the word density is how much of something is there. Fatigability is how quickly the cell becomes tired. Or not cell, sorry, the fiber type. Aerobic capacity, how well does it use oxygen? Capillary density, the amount of capillaries, which are blood vessels around the fiber. Anaerobic capacity, how well it uses glycogen as the fuel. Motor neuron size, so the motor neuron passes the information onto the fibers from the brain. So when you want a more powerful contraction, you're going to need a bigger motor neuron. Then the fibre / motor neuron means how many fibres are attached to the motor neuron. Sarcoplasmic reticulum development. So we're going to look at muscle contractions next week on quite a microscopic level, looking at something called the sliding filament theory. And the sarcoplasmic reticulum is involved in that, and it just allows for a more, the better it's developed, the better the contraction, basically. Twitch type is just whether it's slow or fast. Myoglobin is a form of hemoglobin present within the muscles. What myoglobin does, it binds to oxygen and delivers that oxygen to the muscles. Glycogen stores, it's just anaerobic energy stores, and the sporting examples, well, that's quite self-explanatory. Use this information here to help fill out your table. It's all quite obvious really with the high, low, the moderate, or the small and medium, large. It makes sense when you know what the definition of characteristic is. So like I said, next week we're going to look at the sliding filament theory.